Hey guys, Mr. Enyart here with Mr. Enyart's Mathematical Compositions. This is grade 6, module 6, lesson 6, and we're going to be talking about finding the mean. And they introduce something here called the fair share process. So I'm going to go out and just say this. The simplest way to find the mean is to add up all the numbers and divide by how many there are. You've probably learned that by now if you're on lesson 6 of grade 6, module 6. The fair share process is really just for you to understand how mean works. It's literally evenly distributing, fairly distributing all the data across however many groups there are, which is how many pieces of data you have. So that's why the formula works, because when you add up all the numbers, you're creating a lump sum, and then you're going to evenly distribute them amongst the groups. That's what division is, breaking into equal groups. So the fair share method is a visual demonstration of that, but it's a lot of tedious work. You'll see as I go through this. I don't expect you, and you shouldn't expect yourself to, if you have 30 pieces of data with, double-digit numbers, to draw that with cubes or use cubes to do that. But simply to understand what the mean is and how it works is an important thing, so that you don't get confused with median or mode or maximum or any of the other data points that we use, the terms like mean, absolute deviation. So this is kind of a foundational understanding. So there's a lot of this you can kind of skip through as long as you understand how to find the mean and what the fair share method looks like, and the differences between that and a dot plot. So pay attention to the video, but if you have any questions or concerns, feel free to shoot me an email or message me on Schoology. All right. Okay, so for grade 6, module 6, lesson 6, we're going to start with a simple example, instead of doing all the exercises, of what the mean is. So another way of thinking about mean in data is fair share. And it is about how we can distribute the data equally and find the true numerical center. So there is a formula for mean, and that is to find the sum of all of the data. So you could write mean equals the sum of, I'm just going to write the sum of the data, and you can call it terms, whatever you're using. So I'll use the word terms, but if it's data, it's all the numbers of the data. So the sum of the terms, and you're going to divide that by the total number of terms. So total number of terms. So this is the numerical formula. So let's say we have these 5 pieces of data, and I'm going to use these cubes, or Unifix cubes, but they're just boxes on this app. And we have 1 here, we have 2, we have 2, we have 4, we have 6. Numerically, we can just add those numbers up and divide by 5, because there is 1, 2, 3, 4, 5 groups. And that will give us the mean. And the idea is, what you're doing is, by lumping them all together and then dividing by how many there are, you're spreading them out evenly or fairly. So you could literally move these cubes and try and put them into as fair of groups as possible. And what you'll see is that, oh, hey, look, I'm able to make all of them 3. And all I did was move them around. So the mean here is going to be 3. And so this is what they would call the fair share method, where you're looking at them like this. But in all reality, are you going to draw, if you have 20 pieces of data, all those numbers in Unifix cubes and move them around? No. This is just to help you understand what mean is doing. The mean is to fairly share things, and the formula is to add up all the numbers and divide by how many there are. So the mean should be 3, because that's how it's fairly shared amongst the 5 groups. So now let's just prove that mathematically by adding these all together. 1 plus 2 is 3, 2 plus 4 is 6, and then you've got your 6. And when you add those together, you're going to get 15. And we're going to take that 15 and we're going to divide it by 5, because there's 5 groups, and that gives us a mean of 3. So it works. So let's just jump into the problem set. Again, pause the video, see if you can solve these using the previous data and information you've already learned, and then check back with my video and see if it matches with yours. And if there's any differences, then mark those and let me know what your questions are. So go ahead and pause the video and give it a go. All right, let's go into some solutions here. So I'm just going to show it this way. We have our original data set down here, 4, 1, 3, 2, 1, 7. Each of these represents a successful amount of tosses out of 10 for attempts with this tennis ball. And so here is our fair share or Unifix cube view, right? We have a 1, a 1. I put them in order from least to greatest, right? And then a 2, a 3, a 4, and a 7. Our dot plot would look something like this, right? We have two 1s. We have 1, 2, 1, 3, 1, 4, and 1, 7. And now the idea is let's find the mean by spreading it out and explain how we do that. So we're simply going to start sharing, right, our cubes. So let's just take one of our cubes and, start sharing it with the lower. So maybe I take 1, 7 and I give it to a 1. I'm going to take another of the 7, which there was 6 now, and give it to a 1. Now I've got 3 2s, but then I've got some extra. So I'm going to keep taking from that 7 and give it back to that first one. And take that last one. Looks like I'm going to be putting them into 3s. And bada bing, bada boom. Look, I can move them around, same number of cubes, and I end up with 3 at each group. And so now I have 6 groups of 3 instead of the 2 groups of 1, the 1 group of 2, of 3, of 4, and of 7. And so this is the fair share deal that the chart below is talking about, and just being able to explain yourself through that. And then obviously to find the mean mathematically, we know that we can just add up 1 plus 1 plus 2 plus 3 plus 4 plus 7 and divide that by 6. And since it's 3, I know that those added together will be 36. And 36 divided by 6 will be 3. So far we've been able to evenly distribute fairly all of our cubes in our fair share process. But what if you can't? I mean, we know a lot of times our mean comes out with a decimal or a fraction, right? And this is going to be one of those cases. If you add these numbers up, you're going to get 14. And if you do 14 divided by 4, because there's 4 numbers, you're not going to get a number that does not have a decimal. You're going to get 3.5. So let's imagine for a minute we can still share to where they're all within 1 of each other. Right now, this group has 2 extras, right? 2 more than the other 3 groups. So if we were to say, okay, let's just give 1 here and 1 here, and cross off these 2 because we just moved them. Now we have a 3, 2 4s, and a 3. And because this data is evenly split, we can kind of take this group and imagine it doesn't really exist because it's equally represented over here. So now we're just looking at the comparison between 3 and 4 because we have 2 3s and 2 4s. It's the same as just 1 3 and 1 4 in our comparison. So when I look at the comparison of 4 and 3, what would I have to do to make those even? I'd have to cut this one in half and take the top section of it and move it to here. And so now I have 2 halves there, right? So I end up with 3 wholes and 1 half to evenly share it. And so our mean is going to be 3.5 or 3.5 because 14 divided by 4 is 3.5, which is 3.5. So when doing the fair share method, you try to get it as close to there as possible. And then if you have to cut one of the cubes into fractions to make it even, then that would be your leftover piece. Obviously, the numerical version is much simpler. This is to help you understand, but the numerical version of find the sum of the numbers and divide by how many there are is the quickest and easiest way to find the true mean. So let's see what the next page is. Okay, for the sake of sanity, I hope you didn't actually draw out 30 groups of 14 with blocks. That's a lot of blocks to draw, but that's what this is saying. The mean is the average, right? It's what, if you added everything up and divided by how many there are, this is what it would evenly break into. And so if there's 30 cookies, and obviously they wouldn't all have the exact same amount of chocolate chips, there's probably some differences, but when you add up how many chocolate chips are in each of the 30 cookies and divide by 30, you get 14. So the idea is that I would have 30 groups. We're just going to call this amount 14. and I'd have 30 of those, right? I'd have to draw that 30 times. That's kind of ridiculous. So I'm not going to actually draw that out, but I can explain it to you very clearly. And the dot plot, right, for the second part, we have 30 groups of 14. It's already the mean. We don't know what the individual data was. We just know that of the 30 groups there'd be 40. So we'd have 14 right here, right? We could say this is 13, this is 15, and we would have 30 dots that, of course, would be straight, not looking like that, going up, because that would be how many cookies had 14, based on what the mean is telling us. And for number 5, we're trying to find the mean of the lengths in millimeters of how much these radishes grew in 3 days in identical conditions. So we're going to add up all these numbers. You can use a calculator. Whenever you're doing data, feel free to use a calculator. And then we're going to divide by, let's count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we're going to take the sum and we're going to divide it by 15 to find the mean. So when I added them all together, I got 182. When you divide that by 15, you get 12, and 12 15ths is 180. That leaves you 2 15ths. So in decimal form, that would be 12.133 repeated. And that little line above the 3 3s means it's repeated over and over again for an irrational number. Now, interpreting the value in terms of a fair share mean length, that means that we would have 15 groups of 12, evenly distributed, right? 15 groups of 12, that gives us the 180. And then we have these 2 leftover blocks that we have to figure out where to go. And so those 2 leftover blocks would be what's left of trying to make equal groups of 15. And so we could write it as, okay, we made 15 groups of 12, but then we had 2 leftovers out of 15. And it's out of 15 because that's how many equal groups we're trying to make, right? And so then all we have to do is figure out the decimal form of 2 15ths, which is 0.13333. You can plug 2 divided by 15 into a calculator. You can do it by hand and find out that, oh, this is just going to repeat over and over again. So as far as the fair share mean length, you know what the mean represents.